In this video, we are going to look at some one-sided limits. So on this first example, you'll notice that we're being asked to evaluate the limit as x approaches 0 from the right side. So the plus sign is telling us from the right side. Now, when you think about values to the right of 0, you typically think about your integers, 1, 2, 3, 4. But when we're looking at limits, we want to get as close to that value on the right side as possible. So we really need to look at numbers that are closer than just the integers. So I would probably start my table looking at the value of 1/10, 0.1. And you can just plug that into a calculator using your function that they give you here. So notice when I plug that in, my y value is a negative 609. All right, the next x value that I would probably plug in is 0.01. And when you plug that value in, according to what I get a y value of negative 6,099. So notice that got really small. It's going way down in terms of our y's. And then finally, I would probably do 0.001, which is very close to 0 on that right-hand side. When I plug that into my calculator, I'm at negative 60,000. So we see a pattern here as our x values get closer and closer to 0 from the right. It looks like the y values are just getting smaller and smaller. So they're going to what we call negative infinity. So we would say this particular limit is negative infinity. Now you'll have some textbooks that'll just say the limit doesn't exist, because it's just kind of getting smaller without bound, but this particular book does want you to say that the limit is going to negative infinity. All right, with the next example, you'll notice that we have two different pieces of the function, and different pieces occur for different values of x, and this particular example is wanting us to look at values as x approaches 4, and we're looking from the left-hand side. So we're talking about numbers that are less than 4. So we're looking at this particular piece. Now, if I think about doing a table and numbers that are less than 4 but close to 4, I would probably think of using things like 3.9, 3.99, and 3.999. So again, you can just plug those into a calculator. When x is 3.9, we have a y value that's 5.7. When x is 3.99, notice the y value is 5.97. And finally, when your x is 3.999, your y value is 5.997. And so what you can see here is those y values are getting closer and closer to 6. And so that's what limits are. We're talking about what y value are we getting closer and closer to as your x is getting closer and closer to something. Now, you might just ask, well, why couldn't I just have taken the 4 and plugged it in? 3 times 4 would be 12, minus 6 would be 6. And in this case, you certainly could do that as long as the value exists, and you would get that limit of 6, but just know on a graph that at that particular point, because it does not say x is equal to 4 here, it would be an open point, but still the limit is at 6. So you certainly could do that. If this question had asked for the limit as x approaches 4 from the right-hand side, notice that even though x equals 4 here, when you try to plug it in, you get a 0 in the denominator, and that does not exist. So you are forced to do a table with things like 4.1, 4.01, and 4.001 in that case. All right, then finally we'll look at a graph, and we're being asked for the limit as x approaches negative 4. So this is this x value. And we'll look at it from both sides. So as I'm coming in from the left side, just following the graph, I notice that limit is a y value of negative 4. So as x approaches negative 4 from the left, my function has a y value of negative 4. When I look at the graph and I'm coming from the right-hand side, as I get closer and closer to my x of negative 4, so the limit is x approaches negative 4 from the right-hand side, then you'll notice that this y value is down here at negative 6. Because these do not agree, when they ask me just in general what is the limit as x approaches -4, I have to say that that limit does not exist.